Welcome to the Module 11 Part 2 Calculator Guide video. In this video I will show you how to calculate probabilities using the binomial, and I'm going to go ahead and calculate the probabilities using the same problems we had in the notes. So example 2, looking at the RTD bus that runs 15 trains where each train has a 35% chance of arriving late. So for all of this, we're going to end up using a new list. Now we want to go into our distribution list, which is in blue right here, DISTR, above this button vars next to the clear button. So to get in there, I'm going to do second vars, and now I'm in the list of all of the distributions that we have. So we're going to be using this list quite a bit over the next few weeks. And we want to come down, keep coming down until we see the word binom. So there are two, oops, I went too far. Still going, here we go. Go back up. There are two different binom functions in our calculator, Binomcdf and Binomcdf. Whenever we are being asked a question where we're asking the probability that x is exactly or equal to or is, we're going to use PDF. PDF gives you the probability of exactly that number of outcomes. So it'll give you like the table that we saw on the right-hand side on GeoGebra. Binomcdf, CDF stands for cumulative. So it is going to give you the probability of everything less than or equal to the value that you put in. I'm going to say that one more time because that's very important. Binomcdf gives you the probability of everything less than or equal to the value you give it for x. And we'll see how we're going to have to use that here in a minute. But the first problem asked for the probability of exactly 4 trains arriving late. So we have that word exactly, so that tells me I want to use letter A, Binomcdf. So I'm going to hit enter, and it's going to ask me for 3 things. It's going to ask how many trials we have. So how many total trains are we looking at? 15. What is the probability of success? So there's a 35% chance of a train arriving late. You cannot do math with percentages, so you have to turn the percentage into a decimal. And then the x value, the number of trains that we are interested in. And we're interested in 4 trains being late. So I'm going to hit paste. Okay, if you have a calculator that did not have the fancy menu like mine, this is what you need to have on your screen. So Binomcdf, 15, comma, which you can find above the 7, comma, 0.35, comma, 4. So you're always going to enter trials, probability of success, x value. And we hit enter and we get 0.1792, which matches with what we found in GeoGebra. So now we're going to go ahead and look at the second example, which wanted to find the chance of exactly 3 trains arriving on time. So again, the easiest way to do a problem like this is to say, okay, if 3 trains are on time, and I'm looking at 15 total trains, that means 12 trains are late. So we're going to go back into our list of distributions, and I'm going to show you a shortcut to get to the Binomcdf. So again, this says exactly 3, so that means exactly 12 trains are running late. And I know that Binomcdf is letter A. So I'm going to hit this alpha button, and then right below it in green I have an A here. I'm going to hit that, and it's going to pull me straight into my Binomcdf menu. Now with this, my trials are going to stay the same. I'm still looking at 15 trains. The probability of a train being on time is still the same. The only thing that's going to change is the number of late trains. So 3 on-time trains means 12 late trains. So the x value that I'm interested in is 12. So I'm going to paste that in. So again, if you don't have the menu like mine, your calculator should look like this. And I'm going to hit enter. And we have another instance of scientific notation. So remember that e to the negative 4 means you need to move the decimal place 4 places to the left, and that gives us 0.0004, which matches with what we found from GeoGebra. So now we're going to look at how to use the Binomcdf, and I'm actually going to skip and I'm going to go to letter D from the notes before I do letter C, just because D is going to be a little bit easier in the calculator than E is, or C, I'm sorry. So going to D, we wanted to know what is the chance that at most 3 trains will arrive late. So remember, that was the probability that X was less than or equal to 3. So I'm going to go back into my distributions, and now I'm going to arrow down. I'll show you the shortcut for this one in a second. Keep going, to Binomcdf, which is letter B. So I'm going to go ahead and hit enter. So now we're still looking at 15 trains. The probability of success is still 0.35. And the X value, remember I said Binomcdf gives you the probability of everything less than or equal to whatever X value you give it. So we want the probability of everything less than or equal to 3. So I'm going to put in a 3. And I'm going to hit paste. And we get 0.1727, which again matches with what we found on GeoGebra, which is good. We don't want things to not match GeoGebra. So now we're going to go back to number C, or letter C. Letters, numbers, they're all the same thing. What is the chance that at least 10 trains will arrive late? So this was, remember, the probability that X is greater than or equal to 10. Now, your calculator, as smart as it is also kind of dumb. And it will only give you the probability of something less than or equal to the X value you put in it. So if I want greater than or equal to 10, I'm going to need to use the complement rule with a probability less than 10. Remember, the complement rule is 1 minus a probability. And it's kind of like the opposite probability. So the opposite of having a value greater than or equal to 10 means you have a value less than or equal to 9. So I'm going to type 1 minus, and I'm going to go into my distribution list, and I'm going to use the shortcut this time. So I'm going to hit alpha, and then right here there's a letter B over the apps button. So I'm going to hit the apps button, and that's going to pull me straight into Binomcdf. So my trials and my P stay the same. So if I want greater than or equal to 10, then that means I need to first find everything less than or equal to 9, the opposite direction of what I was looking for originally. And I'm going to hit paste. So we're going to do 1 minus the probability of everything that is less than or equal to 9. That result is going to be everything that is greater than or equal to 10. So I'm going to go ahead and hit enter. 0.0124. That is what we got from GeoGebra. Okay, so your calculator will only calculate less than or equal to. So whenever you're looking at a greater than or equal to or a greater than problem, you have to use the complement rule. So the last one we're going to do is E. This one's a little complicated as well. We're going to take the probability that between 2 and 4 trains arrive late. There's no way for me to tell my calculator that I want between 2 and 4. So what I'm going to do is I'm going to find the probability of everything less than or equal to 4 and subtract everything less than 2. Okay, so I'm going to take everything less than or equal to 4 and subtract everything less than 2. So to do this, I can do this all in one step. I'm going to go to my distribution. I'm going to go to my Binomcdf. I'm going to come down here and I'm going to put in 4 to start. So I want everything less than 4 first. But now that's too much information because I only want between 2 and 4. So now I have this 1 and this 0. Those two probabilities are being included in this number if I were to hit enter, and I don't want those to be included. Okay, you know what? I'll go ahead and hit enter. So the probability of everything less than 4 is 0.3519. But that includes the probability that 0 trains arrive late or the probability that 1 train arrives late. And I don't care about 0 and 1. I only care about 2, 3, or 4. So I need to subtract off the probability that 0 or 1 trains arrive late. So I'm going to hit subtract. And I'm going to do this again. I'm going to go into my distribution list, second vars. I'm going to do AlphaApps to pull me into letter B. And now I'm going to put in a 1 because I want 1 or less. 1 and 0. I want to subtract off those two probabilities. So I'm going to hit paste and I'm going to hit enter. And now we get 0.3378, which matches with what we did in GeoGebra. So there are two added complications when we are doing this in our calculator. If we are doing a greater than or equal to problem, we have to use the complement rule as we did up here. If we are doing a in between two values problem, we need to take everything less than the larger value and subtract everything less than 1 less than the lower value. So 1 is 1 less than 2, so we subtracted off 1 and 0. If I had put 2 here, I would have also subtracted off 2 because it includes whatever number you put here, and I didn't want to do that. I wanted 2 to be included in this final probability. So I have a Word document that I will post that kind of helps you through what you need to put in depending on what the problem is asking of you. And this is something that you will be able to have with you for your exam. Okay, this kind of helpful cheat sheet that I've created. But you have to be able to read the question and understand, is this a less than or equal to, greater than or equal to, or exactly problem to know how to use your calculator to do this. I wish you guys could be able to use GeoGebra, but you just can't. We have to do the calculators. So hopefully this all made sense.